So as we continue using our normal distribution to solve different problems, we'll generally have three types of questions to deal with. The easiest is when we're asked to find the area below a particular value. What's the probability that Z takes a value of less than 1.47? It can help to think about what sort of an answer is reasonable, and to do this we can draw a quick sketch. We know that in our bell curve 0 is in the middle, 1.47 is going to be to the right of 0, and so what we're trying to figure out is the probability below the probability that Z is less than 1.47. Based on my graph, I should intuitively know an answer of more than 0.5 is reasonable. I look up positive Z values on the second page of my Z score sheet, and when I look up 1.47, I get an answer of 0.9292. 92. And now, since it says what proportion of observations on the standard normal variable Z take values less than 1.47, I could say therefore 92.92% of observations take values less than 1.47. Okay. The second type of question involves finding out the area between two Z values or between two variable values. So here we'd always find the cumulative probability up to the greater Z value and subtract the probability from the lower value for it. So if I wanted to know what proportion of observations take values between negative 1.8 and 1.40, then I'm trying to find this shaded area here. In my Z table, I look up the probability that Z is less than negative 1.80. Oops. Negative 1.80 has a value associated with it of 0.0359. I look up the probability that Z is less than 1.40. That has a value of 0.9192. And so then the probability that Z is between those values I get, again, by finding the difference between them, by taking the cumulative probability associated with the greater Z value and subtracting from it the probability of the lesser Z value. This gives me a result of 0.8833. And therefore 88.33% of observations take Z values between negative 1.80 and 1.40. Excellent. So then the final type of question we might be asked is, rather than being below a value or between two values, we might want to know greater than a particular value. So if I want to know what proportion of values in the standard normal Z table take values greater than negative 1.75, again, I think about what that value is. And what I'm trying to find is this shaded region here. What's given on the table is that left tail over there. So in the Z table, when I look up a score of negative 1.75, I get the probability that Z is less than negative 1.75. When you look that up, you get a value of 0.0401. And now if I want the probability that Z is greater than or equal to negative 1.75, since the total area is 1, I subtract the left tail area from 1, and the result is the values that are greater. And therefore, 95.99% of all observations take Z values greater than negative 1.75. There is an alternative approach that we can use. Since our bell curves are symmetric, rather than looking up the negative 1.75 value, I can look up positive 1.75 instead. That would give me the cumulative from the far left up to positive 1.75, and that would be the same as looking up negative 1.75 and looking to the right. So you can check if you look up a Z value of positive 1.75, sure enough, we see that same value, 0.9599, indicating that 95.99% of all observations take Z values greater than negative 1.75 or less than positive 1.75. So there can be different ways to set up or answer the question, but the answers will be the same based on the symmetry of the curve and the answers in the Z table. So again, to practice this, there's some questions here. You can start off sketching your curve. What proportion of the data is greater than 0.33? Draw your curve, mark the 0, think about the 0.33 and what area you're trying to find. Since you're greater, you're looking to the right, and then apply the appropriate method for looking it up. Try those questions out, pause the video, and then I'll include the answers when you replay it. To solve this problem, you'll look up the Z-score value, the probability associated with the Z-score value of 0.33, and then because it's a greater than question, we subtract that value from 1. Your final concluding statement should be that 37.07% of data is greater than a Z-score of 0.33. You can now try the next practice problem. Determine what proportion of data is less than a Z-score value of 1.25. Start by drawing your sketch. Think about whether your Z-score value is positive or negative, and whether you're looking for values less than, greater than, or between two Z-score values. With your sketch drawn, determine the values and formulas that you need from the chart, and then write a concluding statement. Again, pause the video now, try the work, and then resume the video to check your answer. Because it's a less than question, when you look up the probability from the Z table. You can use that answer directly to answer the question. 89.44% of data is less than a Z value of 1.25. Try question 3. What proportion of the data is between -1 standard deviations below the mean and 1 standard deviation above their mean? Remember, standard deviations are what our Z-score measures. So this question is asking us, what proportion of values lie between a Z value of -1 and 1? Pause the video, try to do the calculation, and check your answer. Because this is a between type question, you needed to look up the probabilities for a Z value of -1 and a Z value of 1. Those should both be less than signs. And then find the difference between the values. It works out to let us know that 68.26% of the data is between -1 and 1. Okay. 2 more questions to go. They're both greater than questions. Try them out. What is the chance that a data point is greater than 0.5 standard deviations above the mean? And what proportion of observations is greater than a Z value of -2.65? Start by drawing your sketch. Figure out your Z values you have to look up and what calculations you have to do with them, and then finish with a concluding statement. For question 4, you should find that there's a 30.85% chance that a data point is greater than 0.5 standard deviations above the mean. And for question 5, you should find that 99.60% of observations are greater than a Z value of -2.65. Be sure to try the homework before next class. Topic 7C will work on empirical rule, which will allow for generalization for data sets that have means that aren't 0 and standard deviations that aren't 1, to talk about what percent or proportion of values we expect to find within a certain distance of the mean. Okay, if you have any questions, don't forget to drop in tutoring, book in for regular tutoring, or attend my office hours. Bye.